Scientists say they've discovered signs of a reservoir of liquid water on Mars, deep in the rocky outer crust of the planet. The study, based on seismic measurements from NASA's InSight lander, suggests there may be enough water for a global ocean.
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. And I came across this at the venerable BBC, yes. Reservoir of liquid water found deep in Martian rocks. This should be very interesting indeed. Yes, the discovery comes from analysis of data from NASA's InSight lander, which took a seismometer to Mars. Yes, isn't that fantastic? I love the fact that we can do that now. You know, been doing it for a long time. You know, sending probes, I mean. But to be able to get this sort of information back is incredible. What are we going to do in the future? Hopefully we'll get there with Uncle Elon and it'll be absolutely awesome. Fascinating. All right, my fellow nerdlings, let's have a look. Scientists have discovered a reservoir of liquid water on Mars, deep in the rocky outer crust of the planet. The findings come from a new analysis of data from NASA's Mars InSight lander, which touched down on the planet back in 2018. The lander carried a seismometer, which recorded 4 years of vibrations, Mars quakes, from deep inside the red planet. Oh, it's getting exciting. Analysing those quakes and exactly how the planet moves revealed seismic signals of liquid water. Absolutely fascinating. And there's Earth and Mars. Yes. The InSight mission is set out to investigate the evolution of rocky planets, including Earth and Mars. Look at that. That's our home. One day there will actually be Martians, native-born Martians. It'll be interesting. Yeah, well, probably, and I mean human native-born Martians. Probably are other Martians running around. They're probably hiding every time a rover comes over the hill. They're, oh my God, not again. They've got to go into hiding. Because the Martian communist government has told them that all Earthlings are terrorisms and they want to murderize every Martian. So they have to hide. Every time there's a rover comes over the hill, you've got scattering Martians. Fascinating. Now, while there is, and very stupid too, by the way, David, stop it immediately. Now, while there is water frozen at the Martian poles and evidence of vapor in the atmosphere, this is the first time liquid water has been found on the planet. Now, the findings are published in the Proceedings of the National Academy of Sciences. Now, as usual, I'll leave the link to the main article below the video, so you can pop in, check out these embedded links. Proceedings of the National Academy of Sciences. If you want to go for a bit of a deeper dive beyond the main article, makes for a very interesting read, believe me. I'm feeling a little more energized today, if you hadn't noticed, in the last few days. I've been getting my sleep patterns have been broken, unfortunately, and that tends to drain one's energy. Yes, and you know, got to caffeinate too. Oh God, you'll have to excuse me. I really needed that. Fascinating. Yes, the insides, signed, and I slept the wrong way and everything. You know, you stuff up your shoulder, and yeah, makes it a little difficult to. Interesting. InSight's scientific mission ended in December 2022 after the lander sat quietly listening to the pulse of Mars for 4 years. In that time, the probe recorded more than 1,319 quakes. Now, by measuring how fast seismic waves travel, scientists have worked out what material they are most likely to be moving through. Again, this is fascinating to me. Astrogeology. Astroseismology, I guess. Again, I'm not a scientist. I just love all science. I love sharing these science, space, and tech news, you know, stories with everybody. I'm hoping to build a community where everybody can get together and just discuss this stuff. It's just amazing. If there's anybody out there that knows more than I do, please just feel free. You know, if you're an astronomer or astrophysicist or anyone like aerospace engineer, you know, talking about the InSight lander, I'd love to hear from you. It'd be absolutely fantastic. Thank you. Yeah. Now, these, by measuring how fast seismic waves travel, scientists have worked out what material they are most likely to be moving through. Now, these are actually the same techniques we use to prospect for water on Earth or to look for oil and gas, explained Professor Michael Manga from the University of California, Berkeley, who was involved in the research. The analysis revealed reservoirs of water at depths of about 6 to 12 miles, 10 to 20 kilometers. Now, understanding the Martian water cycle is critical for understanding the evolution of the climate, surface, and interior. said lead researcher Vashan Wright from the University of California, San Diego's Scripps Institution of Oceanography. Professor Manga added that water was the most important molecule in shaping the evolution of a planet. This finding, he said, answers a big question of where did all the water go? Now, studies of the Martian surface with its channels and ripples show that in ancient times there were rivers and lakes on the planet. Yeah, but for 3 billion years it's been a desert. Some of that water was lost to space when Mars lost its atmosphere, but, said Professor Manga, here on Earth, much of our water is underground and there is no reason for that not to be the case of Mars too. Look at that. Absolutely amazing. Martian surface is evidence of ancient rivers and lakes etched into it. Yeah, of course, huge reservoirs of deep water. There's another link for you to check out there. It's fascinating. Now, I've got a little bit of a video from the ABC in Australia. That's the British Broadcasting Corporation, and we're from the Australian Broadcasting Corporation. I've got a video. Let's check it out, and we'll catch up when we come back.
Scientists say they've discovered signs of a reservoir of liquid water on Mars, deep in the rocky outer crust of the planet. The study, based on seismic measurements from NASA's InSight lander, suggests there may be enough water for a global ocean, but it's 11 to 20 kilometres down in the Martian crust. Let's get more on that story now. Professor Michael Manga from the University of California, Berkeley, joins us now. Professor Manga, you were part of this research. It involved a lot of listening, as I understand it. Can you tell us about how this liquid water was discovered?
The Mars InSight team recorded the vibrations of the ground that are produced by Mars quakes and the vibrations produced by impacts that hit the surface from meteorites. The speed at which those seismic waves travel depend on properties of the crust, what the rock is made of, whether there are fractures inside the crust, and what is inside those cracks. And the speed of the seismic waves is best explained by having a cracked crust full of water.
So why is this so exciting to find liquid water?
We know that early Mars had lots of liquid water on its surface. We see evidence for rivers, past lakes, maybe even oceans. Water is very important for the climate. I think people in Australia understand this well. Mars water is also important for habitability. Mars right now is quite dry, and so an open question is, where did all this water go? Some was lost to space, and maybe much of this water is now sitting deep underground in groundwater.
Does this get us closer to answering the question of, is there life on Mars?
It's only a very small part. Life needs water, but it needs more than water. It needs an energy source, and life has to originate. But it does tell us that one place that we should be looking for life on Mars would be deep underground, or places where this deep groundwater may have come back up to the surface.
Speaking of deep, as we said there, it's depths between 11 and 20 kilometres down, so a fair way down. Do we know how much is down there?
If we take all the water stored as groundwater and move it up to the surface, it would be equivalent to an ocean 1 to 2 kilometers deep.
And
so it's a lot of water.
It's a lot. And as you say, it's water that wasn't lost to space, because we know that studies show there was once rivers and lakes, but lost to space. Could this water, deep down, ever be used?
That's an awfully deep well we would need to drill. I think the best way to find that water at the surface would be to look for places where geological activity brings that water back up to the surface. So places that would be similar to springs or along faults where tectonic activity may enable water to come to the surface.
And so armed with this research, what is next for your teams?
It'd be nice to be able to put together this observation of deep water with what we know the water cycle used to be, to try and understand how this water got deep underground and its connection to the water being lost to space today.
Professor Michael Manga from the University of California, Berkeley, thank you for joining us.
Always a pleasure.
Well, that was very, very interesting, wasn't it? Absolutely amazing. Yeah, and it was just good to see with that interview with Professor Manga as well. And as I say, I'm looking very much forward to it. Again, they're very, very deep underground on Mars, these water reservoirs. But, you know, as Professor Manga said, You know, there's got to be somewhere they come to the surface. There's got to be pools of water, or maybe not huge pools of water on Mars, but you know, somewhere we can access that water. It'll be quite, and they're going to be groundwater. You know, you'd have to treat it, but you know, bore water here on Earth is the same. I used to live in places where we had bore water, groundwater, and you used to have to boil it. You know, and you could shower in it, or you could put it on your garden, or whatever the case is. But you know, to consume it, you'd boil it, or whatever the case is. But there's no reason why we can't treat that water and use it for our landers. Use it for our future colonists. Fascinating, isn't it? Yes, the InSight probe was only able to record directly from the crust beneath its feet, but researchers expect that there will be similar reservoirs across the planet. If that is the case, they estimate there is enough liquid water on Mars to form a layer across the surface that would be more than half a mile deep. However, they point out the location of this Martian groundwater is not good news for billionaires with Mars colonization plans who might want to tap it. Yeah, have another low dig at Elon Musk. Jesus, good. It's sequestered 10 to 20 kilometres deep in the crust, explained Professor Manga. Drilling a hole 10 kilometres deep on Mars, even for Elon Musk, would be difficult, he told BBC News. The discovery could also point to another target for the ongoing search for evidence of life on Mars. Without liquid water, you don't have life, said Professor Manga. So if there are habitable environments on Mars, those may now be deep underground. Oh, for God's sake, one, Elon will be able to figure a way of doing it, right? And secondly, he's only got to look for, as I said in that video from the ABC, he's only got to look for somewhere it breaks to the surface. But Elon could do that, for God's sake. Drilling a hole 10 kilometres deep on Mars, how far do ice bores go down in Antarctica? See, typical BBC, having a crack at good old Uncle Elon. Fascinating. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
please, Spock, do me a favor, and don't say it's fascinating. No. But it is interesting.